And welcome everyone, and thank you for joining us today for our webinar titled Online Neural Data Processing with Plexon OmniPlex, Referencing, Sorting, and Online Manipulation. This is Andy Henton from Inside Scientific, and it is my pleasure to be your host for today's event. Our session is brought to us by Plexon and is the second installment in our annual webinar series titled Recording Neuronal Activity in Animal Models. Today's webinar will focus on the fundamentals of OmniPlex software, a turnkey acquisition and data management platform for recording neural biopotentials from acute or chronically implanted electrodes in both anesthetized and awake behaving animals. The presentation will be led by Andrew Klein, Director of Sales and Support at Plexon. Andrew obtained his bachelor's degree with a focus on neuroscience from Bowling Green State University in 2005, and following spent time as a research associate at the University of Michigan before accepting a position at Plexon in 2008. Over the past 12 years, he has focused on applications of in vivo electrophysiology data acquisition and animal behavior analysis. Today, he spends a significant amount of his time traveling throughout North and South America, Europe, and Asia supporting Plexon users. The majority of today's webinar will be spent in OmniPlex software, where Andrew will be showing various functions and features of OmniPlex, including how to optimize signal quality, and how to approach data analysis using multifunction layouts, thresholding tools, data referencing options, and spike sorting functions.
All right, thank you, Andy, for helping Plexon and me with this webinar, and a big thanks to everyone at Plexon for helping make this possible. As Andy said, my name is Andrew Klein. I am Director of Sales and Support at Plexon. Today I will be demonstrating some of the OmniPlex software features. OmniPlex is Plexon's flagship neural data acquisition system. So today we will talk about 4 different topics. The first topic will be layout, the different windows within OmniPlex, how to configure them, how to highlight the ones that are most useful. These are things that we will talk about related to the layout. We will also talk about thresholding and waveform extraction, different means of extracting waveforms from continuous data. It's possible to do this manually and automatically. We will talk about this. We will also talk about referencing, some of the different hardware and digital referencing options available in OmniPlex. And lastly, we'll talk about spike sorting, highlighting 2 different methods for spike sorting online. There's a few important details to talk about first. There's 2 pieces of software associated with OmniPlex, OmniPlex Server and Plex Control. These 2 pieces of software work in a server-client relationship. Most of today's webinar will be spent doing things in Plex Control, although we will periodically be making changes to settings in OmniPlex Server. The bulk of the user experience for OmniPlex is in Plex Control. This is why we will spend most of the time today in this software. Next, things like hardware configuration, data flow, getting started with data in the system, etc. will not be covered today in the webinar. These details are well documented in the OmniPlex user guide, which is available on the Plexon website and made available at the end of this presentation. The data that we will be looking at today is 8 channels from a previous recording session. It's not simulated data, but it is pre-recorded and played back into the OmniPlex system. And lastly, the software we'll be using today is OmniPlex Release 16. This is the 16th release of the OmniPlex software. So let's get started. The first topic is layout. Within OmniPlex, each data type has its own visualization window, which is displayed with the default layout. The user can customize a layout and highlight only the most useful windows. It's possible to save custom layouts to a file as well. This file is called a PXC file. So we'll jump right into Plex Control. This is the default view for Plex Control. Each one of these black windows is a different window that we have displaying some type of data. As we click in these windows, the bar above it will turn orange. That's how we know that we have that window selected. For right now, we'll talk mostly about the continuous window. The continuous window is down here at the bottom. This shows all of our continuous data that we have available to us right now. There are 4 types of continuous data streams within OmniPlex. There's wideband, continuous spike, field potentials, and auxiliary analog inputs. It's important to note that all modern OmniPlex systems come equipped with 32 auxiliary analog input channels for continuously acquiring signals not acquired by the head stage. Some examples of this might be eye position data, EMG, blood pressure, etc. So within the continuous window down here, there's a number of tabs. Each one of these tabs corresponds to a different signal type. There's the SPKC, which is our spike continuous. There's the FP, which is our field potentials. There's the wideband, which is our wideband data. There's also the AI, which is our analog inputs or auxiliary analog channels. We will not be doing anything today with the auxiliary analog inputs, so I can hide this window from view. The best way to do that is to click on the window, pull it out from all the other tabs, and press the close button. Likewise with firing rates, I'm not going to be doing anything with firing rates today, so I'm going to click on this window, pull it out from all the other tabs, and close. Now I'm visualizing my wideband signal. I can visualize my spike continuous signal. The bulk of what we will be doing today with referencing and thresholding and sorting will be based upon the spike continuous signal. We'll be spending a lot of time looking at this data here. To orient ourselves a little bit, this is 4 channels of data, the first 4, channels 1, 2, 3, and 4. Each one of these menus has a drop-down menu. Each one of these windows has a drop-down menu that can show us some additional settings, things like increasing the sweep speed, or looking at more channels, looking at fewer channels, changing the magnification, things like this. Since this window here, since any of our continuous windows are based upon time, the x-axis is time, I would like to make this window as large as possible. I can do that by grabbing the side of the window and pulling it over to make it larger like any typical Windows application. But the problem with this is that the other contextual windows then are also manipulated. So a different way of doing this would be to undock this window from all the others and move it to somewhere else, somewhere where I would prefer it to be. So the way to do this is to grab the window itself, pull it out from all the others, and dock it at the bottom of the screen. Now I've docked all of our continuous windows. You can see all the tabs are down here. I've maximized the x-axis so I can see time in a greater scale. I can make this window larger. I can double click to zoom in. Now I'm looking at one channel of my data, channel 1. This is a useful means for manipulating the data to how I want to see the data that I'm looking at online. Each user will have their own preference for how to configure windows and look at different visualizations that are important. It's possible to save these configurations with a PXC file. This is a Plex control configuration file. This can be useful for using the same layout and same configurations tomorrow or the next day. It can help if there's more than one person using the same system, or maybe there's different recording experiments or different experiments that will rely on different types of windows or different types of data that are most important. So to come back to PowerPoint and to recap what we just talked about, there's a different organization to the different windows in OmniPlex. It is easy to customize the different views to highlight the data windows most important to the specific experiment, and it's useful to save the layout so it can be used in the next experiment. Okay. The next topic we'll talk about is thresholding and extraction. Waveforms can be extracted from the continuous spike data online during acquisition. Thresholding is one way to extract a waveform or spike. There are 2 different ways of thresholding with OmniPlex. There's the standard extraction method, where a spike's timestamp is the time at which it crosses the threshold, or there's a aligned extraction, where a spike's timestamp is the point of the maximum amplitude. This is all online. Along with the extraction point, it's important to talk about how much of the signal is captured. This is the waveform length and the pre-threshold length. I'm going to demonstrate standard and aligned extraction using manual thresholding now in Plex Control. We'll jump back into Plex Control. What the thresholding that we're going to do is be on our continuous spike signal here. I'm going to manipulate my windows a little bit more just so we can see things a little bit easier. I'm also going to double click to zoom into a channel, so we're only looking at one channel. So channel 7 is a channel that has some pretty good spiking information on it. I'm not seeing anything in this window up here, which is our selected waveforms window. And I'm not seeing anything in our array of waveform window. The reason for that is because nothing is crossing the threshold yet. In our waveform view, this blue line here is our threshold. If I click on this and pull it up close to the 0 point, we'll see that signal now is crossing the threshold. That blue line is also down here in the continuous view. It might be a little bit difficult to see, but the blue line is right here. I can adjust the line here. I can adjust the line here. Adjusting it in either place is exactly the same. I can drop my menu down in my waveforms view. I can increase my magnification and start to see what the waveforms look like that are crossing the threshold. Note that whenever the signal crosses the threshold, it's being extracted. If we increase our sweep speed and pause the display, we can see where the signal crosses the threshold, and we can see a white line or a tick mark which corresponds to the timestamp of that threshold crossing. What's being shown in the waveform view is the last 500 waveforms to cross the threshold. They're all being aligned to the threshold crossing. That's this point here. This is the standard extraction method. It's also important to note how much of the signal is being extracted around this threshold crossing. That's set in the waveform length and the pre-threshold length in our properties view over here. By default, this is 800 microseconds with 200 microseconds before the threshold. That means that there's 800 microseconds total length to the waveform, 200 before the threshold, 600 after. We can see, though, in this example, some of our waveforms, though, haven't resolved themselves yet. The reason for this is likely that the length of the waveform is longer than our waveform length setting. Just because this is the default doesn't mean it is the best. So we can change this value. To do this, we have to stop data acquisition. We can increase this waveform length. Let's increase it up to 1300. That's 1300 milliseconds. 1300 microseconds. We can also change the pre-threshold period. Restart data acquisition. Now it's important to note that we haven't changed the threshold at all. We haven't changed the position of the threshold or hypothetically where the signal crosses the threshold. What we've changed is the amount of signal extracted around the threshold crossing. Now we're extracting 1300 microseconds or 1.3 milliseconds around each threshold crossing. The benefit of this is now we can see some better definition or better separation between some of our thresholded waveforms. This should be useful when we start to spike sort. This is manual thresholding using the standard extraction method. It's a standard extraction because all the waveforms are being lined to the threshold crossing. We can change that to be the aligned extraction method. Remember, with aligned extraction, the spike's timestamp is the point of the maximum amplitude. Also note that we have some noise in this recording. We'll try to address some of that with our referencing, which is coming up in the next section. But to change to aligned extraction, first what we have to do is stop data acquisition. And the thresholding options are set in OmniPlex Server, which is the other piece of software associated with OmniPlex. That's the server. So if we go back to that, this is our first look at OmniPlex Server. It's an opportunity to introduce some of the features of this. Really, you can think of OmniPlex Server and the topology file that is loaded inside of it as a visual representation of the signal and processing pathways of OmniPlex. Within OmniPlex, there are visualizations and configurable options for all different data streams. Details of OmniPlex Server are well outlined in the OmniPlex user guide. So what we will be doing today is changing something in the thresholding module. We're going to right-click, say Edit Device Options, and change the timestamping mode from use the time of the threshold crossing to use the time of the largest peak. We hit OK here, and we go back to Plex Control and restart data acquisition. We haven't changed where the threshold is positioned. We haven't changed the waveform length or the pre-threshold period. What we've changed is how the waveforms are aligned. Now they're being aligned to the maximum amplitude. This helps us to further differentiate some waveforms of interest. The position of the threshold and waveform length, pre-threshold length all stay the same. What is different now is the waveforms are aligned to the maximum signal, not the threshold crossing. This can be useful for better separating spikes without changing the threshold. This can also be useful for spike sorting. Whether or not standard or aligned extraction is used will depend on how well isolated the data is, the noise level, how detailed the spike sorting must be, user preference, etc. So that was a demonstration of manually setting the threshold using the standard and aligned extraction methods. If we go back to PowerPoint, oops, we can also talk about automatic thresholding. With OmniPlex, it is also possible to set the threshold automatically, which will be more useful than the manual thresholding method just described. This is done by first taking a snapshot of continuous spike data. Think of a snapshot as a brief snippet of data that we can do some calculations on. By default, once a snapshot is available, the software will calculate a mean and standard deviation of the signal in the snapshot. Then the user can choose to set the threshold to a certain number of standard deviations away from that mean. So if we go back to Plex control, let's go to channel 6 here now. We haven't set the threshold on channel 6. That's why we see no waveforms in our waveform arrays view and no waveforms in the specific waveform channel. Down here, we're visualizing the continuous spike signal for channel 6. There's an option in here called snapshot options. We click in here. This tells us the size of the snapshot buffer, which is 10 seconds by default. This is the size of the snapshot that will be collected. Since it's a continuous variable, it's a matter of time. We're capturing 10 seconds worth of data. When that new snapshot first becomes available for the channel, we're going to perform an auto thresholding. Those options live in the auto thresholding options. The auto thresholding is based upon mean and standard deviation. Once that snapshot is available, the system will calculate a mean, it'll calculate a standard deviation, and it'll set the threshold by default to 4 standard deviations, 4 sigma away from the mean. So let's do that right now. So there's a button here that says Start Forward Snapshot Collection for Channel 6. This will only do the snapshot on channel 6. Once we press the button, it starts collecting 10 seconds worth of data. Down in the bottom right-hand corner, it tells us it's collecting this snapshot. Once it has 10 seconds, it will calculate the mean and standard deviation and set the threshold so it's however many standard deviations away from the mean we had chose. By default, it's 4. Here we can see the results of that threshold, that threshold, automatic threshold that we set. We can make an adjustment to this if we didn't like the value. We can come back into our snapshot options, back into our auto thresholding tab, and change this value from 3 to 4 or from 4 to 5, whatever we decide. Making that change, we can say OK. And now, since we already have a snapshot, we can just say perform an auto threshold on the current snapshot, and it'll adjust that threshold to 3 sigma instead of 4 sigma. So there's 2 benefits of automatic thresholding. It enables us to set the threshold on a channel in a programmatic way. It also allows us to set the threshold on all the channels using the same method. So we can do that. Instead of setting the threshold on channel 6 and then channel 5, 4, 3, etc., we can double-click and zoom out in this view, visualize more than one channel, and now this Start Forward Snapshot Collection button says for all the channels and not just channel 6. So now when I press this button, it starts collecting a snapshot on all 8 of my channels. It calculates a mean and standard deviation on each channel snapshot, and it'll set the threshold for each channel based upon that equation. So 2 benefits of automatic thresholding. There's this, it enables the user to set the threshold on lots of channels at the same time using the same method. It's important to note we're using the same method, not setting the threshold to the same value. It also allows for a layer of objectivity when setting the threshold. Size of the snapshot buffer and number of sigma used to set the threshold is easily changeable. Changing these settings and rerunning the auto thresholding will result in different threshold settings. So let's recap. We've talked about manual spike extraction, which is possible with two different methods. There's standard extraction. The timestamp of the waveform is when it crosses the threshold. There's aligned extraction. The timestamp of the waveform is the maximum amplitude. We talked about automatic thresholding, which is possible by taking a snapshot or snippet of the continuous data. The threshold is set to a number of standard deviations from the mean. This allows for the thresholds to be automatically set on one channel or all the channels. It also introduces a layer of objectivity to the thresholding process. The next thing we'll talk about is referencing. During the previous demonstrations, we could see that there's some noise in this recording. Some examples of noise sources might be movement artifacts, an electrically noisy piece of equipment adjacent to the recording setup. It could be electrical noise from the power supply. This is typically called 50 or 60 cycle noise. With OmniPlex, there are two ways to use referencing to improve a noisy recording. One way is hardware referencing. This referencing occurs before A to D conversion. In other words, the noise isn't recorded. This type of referencing is typically achieved with a dedicated reference electrode in the brain. The reference electrode is adjacent to the other recording electrodes. The reference electrode will have a different impedance than the recording electrodes so as to pick up similar artifacts or noise as recording electrodes, but not similar signals of interest. This type of hardware referencing with dedicated reference electrode is optional. Without setting the system to use a dedicated reference electrode, the system will use the ground electrode in the array by default. Something that we can demonstrate today is software or digital referencing. This is another option for getting rid of noise. This is where the reference is applied to the already digitized signal, but still online. There are two options for software or digital referencing. There's channel referencing, using one recording channel as a reference for others. It's important to note that the channel selected to use as a reference in this way should have common artifact to the other channels, but not common signal of interest. The other option is common average referencing or common median referencing. This enables the user to use the average or median of a group of channels as the reference. Let's jump back into Plex control. It might be the case that the displays that you're seeing here aren't updating over the webinar as quickly as they are for me. Know that when you're doing it yourself, you should be able to see this in a much clearer way. So for channel referencing, this occurs in the properties spreadsheet, which now for us is all the way to the right. There's lots of information in the properties spreadsheet. We can enable and disable channels. We can look at threshold values. We can enable which signal types on each channel to record into the file. We can also look at digital referencing. Each row corresponds to a channel. Each column corresponds to something that you can change. The two columns on the right, labeled dref SPKC and dref FP, correspond to the digital referencing that you can set on the continuous spike channel and an independent reference that you can set on the field potential channel. With an OmniPlex, it's possible to digitally reference your field potentials differently than your spikes. Within each channel, there's a drop-down. First, we'll look at channel referencing. All these channels, all the channels listed here, are all the channels that we have available to select as a reference. We only have 8 channels worth of data that we're playing here, but we're using a 32-channel system, so that's why we see 32 channels here. I happen to know that channel 5 is a good candidate for a reference. The reason I know this is because it has a common movement artifact or a common artifact to all the other channels. We will see this come up periodically, but more importantly, channel 5 has no spikes. You can look at channel 5 here by clicking on our waveforms view. Let's look at channel 5. I want to be able to look at these array of waveforms and also my property spreadsheet at the same time. I can manipulate my layout to do so. The best way to do this is to grab my property spreadsheet here, pull it away from all the other tabs, and dock it right next to my waveforms. Now I have my individual waveform, I have my array of waveforms, and I have my property spreadsheet. This is another example of manipulating the layout within OmniPlex to change the visualization specific to the user's preference. So I'll manipulate the windows here a little bit so we can see things. So let's go back and talk about referencing. So I want channel 5 to be the reference for all the other channels. So channels 1 through 8 will use channel 5 as the reference. In this drop-down, I can select channel 5 here. I can select channel 5 here. I can select channel 5 here. This might be not too bad for 8 channels, but it would be pretty difficult with 32 channels. With hundreds and hundreds of channels, it would take you all day. The best way to do this very quickly would be to highlight all the channels that you want to set the reference to. Would be to highlight all the channels you want to set the reference to. And so long as the top channel is set to how you would like it, you can right-click, say set all selected channels like topmost selected channel, and what that will do is set all the channels that you had highlighted to whatever the top one was. So what we've done now is for channel 1, 2, 3, 4, 5, etc., we've set the reference now to be channel 5. Note that channel 5 still says none or no reference. The reason for this is the channel being used as the reference cannot itself also be referenced. That's channel referencing. We're now using channel 5 as a reference for all the other 8 channels. Channel 5 is being subtracted from the other 8 channels. That was channel referencing. Also in this drop-down, we'll see towards the top, CAR, multiple CARs, and CMR, multiple CMRs. The way this works is as you set channels to be CAR, it's only those channels that are set to CAR that will be using that reference. So now in my example here, channels 1, 2, and 3, the average of those channels is being used as the reference. It's very important to note that CAR and CMR works best the more data that you put into the equation. We recommend more than 16 channels at least for CAR. It's a useful way for getting rid of signals, for referencing on signals that might be common amongst a whole bunch of channels, especially if you don't have one channel without a signal of interest. This can also be useful for if there's multiple implants or areas being recorded from. Another option could be if you have multiple animals being recorded with the same system. You have multiple CARs, you have multiple CMRs. CAR stands for common average referencing. CMR stands for common median referencing. I'm going to set all of them back to channel 5 because that's what we'll be using for the rest of the webinar. So now we're back to using channel 5 as the reference. So to recap, we've talked about hardware referencing. This will affect how the data is acquired. It happens before A to D conversion. The user has the option for setting a dedicated reference electrode. Without setting a dedicated hardware reference, the ground of the implant is used by default. We also talked about software digital referencing. This is a means to improve the quality of already acquired data online. One option is to use channel referencing. This is most useful when one channel has an artifact or noise common to other channels, but no common signal of interest. Another option is to use the average or median as a reference. This is most useful when all channels have a common noise and common signal of interest. CAR and CMR works best with lots of channels. Next, we'll talk about spike sorting. This is the last topic. Spike sorting is the classification of waveforms. It's possible to do this online with OmniPlex. Online spike sorting is optional. It's always possible to do all spike sorting offline in offline sorter, or even change the online sorting done online in offline sorter. Spike sorting allows the user to make some general determinations of what is happening online. There are 5 different online spike sorting methods available in OmniPlex. We're going to highlight 2 in this webinar. The first one is line sorting. This is based upon waveform shape. The next will be 2D polygon sorting. This is based upon the waveform's projection into feature space. If we jump back into Plex control, we're going to do some line sorting first. I'm going to sort on channel 7. Let's make these windows a little bit larger so we can see. Remember, line sorting only applies in waveform space, so I want to make this window as large as possible. Likewise, I want to double-click to zoom into my spike continuous signal, so I'm only looking at channel 7. This is just a personal preference. Remember, with OmniPlex, we have the ability to change the layout to many different options based upon personal preference. So with line sorting, the way I'm going to do it is I'm going to take a snapshot. A snapshot is 500 waveforms when we're talking about a thresholded signal. That's this button here. I'm going to take a snapshot. Now what's being shown to me is the last 500 waveforms to cross the threshold. 500 is an arbitrary number. That's the default. This can be changed based upon user preference. So when I'm visualizing the snapshot, I have the ability to add a unit. When I click the Add a Unit button, I'm able to draw a line through a group of waveforms. Now it's only the waveforms that are plotted through that line that are sorted as part of that unit. What's useful about line sorting now is I can add additional lines. I can add a line here. I can add a line, let's say here. I can even change what I'm being showed to only show me the selected unit. And now I'm only showing the waveforms within the snapshot that are crossing that line. This helps me to really narrow in the sorting and get very, very specific. I can always manipulate this or change it offline, but online I have the ability to get very, very specific with how I'm going to spike sort this. So now I can turn the snapshot off. I can go back to show me everything. Now as new waveforms cross the threshold, if they're plotted through all 5 of those lines associated with unit A, they will be sorted as part of that unit. This is line sorting. I can go back to my snapshot, add another line, or add another unit. Now if the waveforms aren't plotted through the unit A's lines, and they are plotted through unit B's lines, they will be sorted as part of unit B. If I go and look at the selected unit, I can see I didn't do exactly a real great job. I can add some lines to improve this. It's possible to sort on incoming data or on snapshot of data. What I've done here is I've categorized waveforms online based upon lines that I've drawn on the screen. It's only those waveforms that are plotted through those lines that will be sorted as part of those units. Down here in the units window, I can see how good of a job I'm doing with my sorting. Line sorting allows the user to get very selective with the sorting. Another view or window useful for spike sorting is the cluster view, or which is another name for feature space. The cluster view is here. I'm only seeing results on channel 7 so far because I've only taken a snapshot on channel 7. If I want to look at these clusters along with my waveforms, I can do this docking trick and add it as another column here of data. I can click on my clusters, I can pull it out and dock it next to the array of waveforms. Again, I'm customizing the layout based upon my personal preference. I could save this as a layout, I could save this as a PXC file, I could save this at the end of my recording and jump right back into it the next day by loading a PXC file. So we'll need to take a snapshot on all the rest of my channels to see the PCA results. I can drop my menu down, take a snapshot. Now I've got some PCA results, turn the snapshot off. Now I'm visualizing those. I can double click to zoom in. The scroll wheel allows me to change my 0 point, or the zoom, the shift key will allow me to change my 0 point. The reason I'm pointing this out is that it allows you to see how good of a job you're spike sorting. Each waveform is plotted in feature space. Here by default, the features are the first and second principal components. The x-axis is PC1, the y-axis is PC2. This window can be very useful to visualize and evaluate online the spike sorting results. Cluster space is also where we do 2D polygon sorting. Now that we've looked at this view, we can do some sorting using the 2D polygon method. To do this, we have to stop data acquisition. And down in our properties view on the left, I'm going to change my sort method from line sorting to 2D polygon sorting. I'm going to restart data acquisition. 2D polygon sorting is a method that only takes place within the clusters window or feature space. We see no PCA results here because we haven't yet taken a snapshot of the thresholded waveforms since data acquisition was restarted. So I'll take a snapshot on channel 7. When I do that, I have a sorting menu below. I have an option for define new unit. I can click define new unit. And now in this method, I draw a contour around a group of points. The way this sorting method works is it's only those waveforms that are plotted within that contour that will be sorted as part of that unit. When I turn the snapshot off, that projection stays within feature space, and as waveforms are plotted within the contour I drew, they'll be sorted as part of that unit or left unsorted. I can change the position of that contour. I can go back to my snapshot to find another unit. I can add a third unit. I can redraw units. I can delete units. It's only the waveforms that are plotted into those contours that will be assorted or assigned to those units. Unit A has priority over Unit B, has priority over Unit C, etc. With 2D polygon sorting, it is also possible to do auto sorting. By default, the OmniPlex system uses the value-seeking method for auto sorting. The value-seeking method includes a unit finding sensitivity control called the Parkinson multiplier. Generally, with the value-seeking method and the Parkinson multiplier, you reduce the number to find more clusters. That value by default is at 0.7. So let's go to another channel. We'll look at channel 6 here. We see no PCA yet because we haven't yet taken a snapshot on channel 7. Let's go ahead and take a snapshot for all of our channels. We can go back to channel 6 here. Zoom in a little bit. Maybe we can change our 0 point. So now, if we take a snapshot, we have the define a new unit button. We also have the option for automatically find the units. By default, this value is at 0.7. We can adjust this number to 1.0 and see what kind of results we get. And say automatically find units. And it automatically finds the units based upon that value-seeking method and the Parkinson multiplier. As we adjust this number, we'll get different results. The results that we get will be dependent upon how well isolated the data is, how many units there are, how noisy it is, etc. This is pretty well isolated data, so we got the same result with the same with 2 different values. Let's go to a channel like channel 8, which is not so well isolated. Here we can take a snapshot, see what the value looks like at 1.0. It did a pretty good job of finding both of those units. It'll typically find the noise cluster as a unit. If there is noise, if you have included some noise in the piece in the thresholding, we can manipulate this some if we want to. We can adjust the setting. We can change exactly how these, maybe you want them to overlap, or maybe you want the sorting to be just a little bit different. How good of a job the auto sorting method does will depend on the data that is used. In other words, the data in the snapshot. It can also depend on the method of sorting, the parameters of the sorting method, for example, the Parkinson multiplier with the value-seeking method. Lastly, it's possible to auto-sort all the channels within a source using the same method. That's up here in the Configure window, Configure Auto-Sort Current Source. Our source that we're currently visualizing is the continuous spikes. If we were to do this, it would auto-sort all the channels together. The parameters that are used are set in the snapshot options. It's going to use the value-seeking algorithm with a Parkinson multiplier of 1 by default. We could adjust this. It says 1 here because we had selected it 1 up there. So to recap, we talked about line sorting, which is a method for sorting based upon waveform shape. This is useful for when waveform isolation is especially poor. Multiple lines can be added. You can change the view, add lines, change the view. This sorting method enables the user to get very selective with the sorting. We also talked about 2D polygon sorting. This is a method for sorting waveforms projected into feature or cluster space. It's easy to make slight adjustments to the sorting, and with 2D polygon method, auto sorting is also possible. So to summarize what we all talked about today, we talked about a lot. We talked about layouts. OmniPlex has many different data visualization windows. The user can highlight the visualization windows that are most important. We talked about thresholding or extraction. OmniPlex has two different means for waveform extraction. There's the standard method, where waveforms align to the threshold crossing. There's the aligned extraction method, where waveforms aligned to the maximum amplitude. Auto extraction is also possible. This is based upon a snapshot of data, a mean, and standard deviation. We talked about referencing and the differences between hardware referencing and software or digital referencing. There are two different methods for online digital referencing. There's channel referencing. There's common average referencing or common median referencing. We also talked about spike sorting, which is an optional online classification of waveforms. There's 5 total methods for online spike sorting with OmniPlex. We highlighted 2 of those methods. We highlighted line sorting, or classification by drawing lines and sorting the waveforms plotted through those lines. We talked about 2D polygon, which is classification by drawing a contour in feature space, and only the waveforms that are plotted into that contour will be sorted as part of that unit. Using 2D polygon sorted, we demonstrated the value seeking method for automatically sorting. Lastly, at the bottom of the window here is a link to the OmniPlex user guide, which has a lot of this information and specific information about getting started with OmniPlex. This user guide is also available in the Go to Webinar handout section. That's all I have planned to talk about today. I'm available and willing to talk about any other details and try to answer any questions. Thank you for your time and attention.
Thank you, Andrew. That was great. A wonderful presentation. And yeah, we've got just over 10 minutes now for Q&A. So let's get right into that. First question for you is, when using 2D polygon sorting, how does the system determine which unit to assign a waveform to if the waveform is plotted in 2 or more overlapping contours?
Thanks, Annie. Yeah, that's a good question. I think the best way to demonstrate that would be just to go right back into the software here. If I come back into Plex Control, there's an example right here of 2 overlapping 2D polygons. So the way OmniPlex works is that each waveform can only have one classification. It can either be sorted or unsorted. A waveform cannot be sorted into 2 different units. It can either be sorted or unsorted. If it's sorted, it can only be categorized to 1 unit. So when they overlap, what happens? That is a setting in OmniPlex to decide what's going to happen in this case. I'm going to stop data acquisition here. I'm going to go back to OmniPlex server into the sorting option. I'm going to right click, say edit device options, and here I have an option to decide how the system will handle 2D polygon overlaps. So by default, it's nearest to the centroid will win. So that's how the system is handling those overlaps. So I can hit OK, go back to Plex Control, start it up again. That's how the system is handling those overlaps. It's a good question.
Perfect. Thank you. All right. Another question, when using CAR or CMR, is it possible to see or better save the value that is being used as the reference?
Yes, that's also a good question. Let me manipulate these windows a little bit to see this property spreadsheet a little bit better. Okay, so down in our referencing option, when we look at this drop-down menu, there's the option for multiple CARs and CMRs. That means we can have 4 different groups of channels, each using their own average, or 4 different groups of channels using their own median. There's also the option for CAR MON, or CAR2M stands for MON, 3 MON, 4 MON, etc. The MON here stands for the monitor. So if I selected 10 channels to be CAR1 or CAR, and I had an 11th channel that didn't have any signal that I was interested in, I could set channel 11 to CAR-MON. And what that will be now is, instead of it showing me what the data from electrode 11, it would be showing me what exactly that average is. So it's a way of monitoring what's being used as the reference. This is very useful, as it can be tricky with CAR or CMR because it's not exactly easy to figure out what exactly is being used as the reference. Yes, we know it's the average, or we know it's the median, but what exactly does that look like? Without a monitor channel, we're not able to tell. So we can visualize that online and just keep an eye on the average that's being used for those channels. We strongly recommend using a monitor channel whenever using CAR or CMR. But it's also possible then to record that channel if we wanted to visualize it or use it offline. So if we select channel 11 to be the CAR-MON and we decide to save channel 11 to our data file, what will be on channel 11 then is no longer the electrode from the head stage channel 11. It's actually the average of the channels that we had set to CAR. It's another good question.
Perfect. That's great. Okay, a question from Dekra. He says that I have a problem with some of my spikes not being aligned with the rest of the spikes. As a result, these spikes do not cluster well with the other waveforms, making it seem as though they come from a different neuron. So it says, I have tried aligning the waveforms based on peak after acquisition, and I've also tried different threshold levels during acquisition. But the latter often leads to a large data set that I feel can be more accurately sorted. So how should I approach sorting this type of data set?
It's a good question. I think there's a number of different things that could try. One is trying this aligned extraction online. You know, he said that he's trying the alignment offline. Trying it online and seeing what kind of results it has online could be useful. And looking at aligned extraction and then potentially adjusting the threshold based upon the results that you get would be another way of trying to better differentiate more than one neuron on the same channel. Something else to try would be to try some of the digital referencing options available in OmniPlex. This can help to clean up some of the data and make the waveforms that are of most interest more obvious to the user online. Those are two things that I would recommend to try online. Offline and offline sorter, you have different options. You have options for like dual thresholding. You have options for automating a whole bunch of different thresholding calculations to see which one might be best or give the best results. What's nice about that is if you decide in offline sorter what thresholding options work well for your type of data, you can go back online and try those same settings online. So just because you have the option to set those settings online, sometimes it can be difficult to figure out what the best settings are as data is being acquired. Trying to figure that out offline as after the data is acquired might be a little bit easier or more useful.
Okay, that's great feedback. Another question, how is the continuous field potential view different from the continuous wideband view?
Great question. So the wideband signal, or what we're visualizing here, let's go to, like, for example, channel 7 here. I'm going to expand this, make it a little faster. The wideband signal is effectively everything that is being acquired at the head stage or by the system. This is the widest bandpass available to the system. So this includes all the low frequency signal and all the high frequency signal. It's the wideband signal then that is filtered one way and turned into the continuous spike signal. So we filter it and get rid of everything below a certain frequency to turn it into our continuous spikes. This is what we then use to derive our waveforms. But we take that wideband signal and filter it the opposite way and only look at the very low frequency signal. So now we're getting rid of everything that's above a certain frequency. So the data that's in the field potential, the data that's on the field potential channel is also present in the wideband signal. The difference is the wideband signal also contains all the high frequency information things like spikes.
Perfect. Okay, a question from Anna. Can the thresholding mode also be set or adjusted in offline sorter?
Yes, absolutely. So one important thing to know, though, is if you want to re-threshold data offline, you have to be sure to save this continuous spike data. There's an option up here in our properties spreadsheet to record the spike continuous data. What this means is that you can select on a per channel basis whether or not you're going to record this continuous spikes. The reason that has to be recorded is if not, then all that's being recorded is just what's crossing the threshold. And if you adjust the threshold offline, you want to know what's maybe slightly before or slightly after your incorrect threshold setting. So you're able to get more or less or different parts of the waveform. So yes, it's absolutely possible to do thresholding offline. You can do the standard method. There's some different alignment methods. You can do it automatically. All those options are available in offline sorter. Likewise, you can write a batch command to batch process data or batch threshold data if you wanted to. So if you wanted to automate things even further. The scope of this webinar is not really to talk about batch processing and offline sorter, but I think that's probably a good idea for a future webinar.
Great. Very good answer. Okay, I think we've got time for a couple more here. David has asked, I wish to set a field potential range of 180 to 200 hertz in Plex server to monitor hippocampal ripples during electrode implantation. How would I do that?
So the best way to do it would be to change the filter settings of the field potential separator. So by default, the field potential separator only has a low pass setting. By default, I believe it's 200 hertz. The high pass setting is then set in the head stage or maybe set in the amplifier, depending on what variety of OmniPlex system that you have. But it's possible to then set some range there to only look at a certain range within your signal. Or one view that you could look at if you just wanted to visualize these things would be the field potential spectrogram, which is another view that you have. So within this view, this is a spectrogram for whatever the selected channel is. For us right now, it's channel 7. In the options here, we can increase things like our amplitude scaling. We can start to look at some higher or lower frequencies, but you can also in the options set what the frequency range is. So if you only wanted to look at a certain frequency range and try to pick out slow or fast ripples or some specific region of interest or area of interest, you could do that online here. So you would still be looking at all of the field potential data, or essentially all the data below some low pass filter, but here you could also only parse out a specific part of it with the spectral view.
That's fabulous. That's a great answer. Very good. Okay, last question. Kayla has asked, can you alter your referencing while recording? For example, if you notice that a unit is being reflected in every channel.
Yes, you can. That's potentially a dangerous thing to do.
Okay.
You can change. If you were saving your spike continuous data while you were recording to file, you could change your referencing. It's probably not a great idea to do, because then you'd have some part of the file that didn't have certain channels referenced in a way, and another part of the file that had channels referenced in a different way. One way around that would be to record 2 different files. Another way around that, maybe a better way around it, would be to also record the wideband along with any channels that you're interested in. So if you've got 4, 5, 6 channels of your array that you're really interested in, record the wideband channels for the wideband data for those channels. The reason for that is the digital referencing that you're doing does not apply to the wideband data. So saving the wideband data effectively allows the user to save a raw copy or a unchanged copy of whatever you did to the channel online. So if you did all kinds of thresholding and all kinds of different extractions and sorting and referencing and all that kind of stuff, and potentially wanted to undo some of that afterwards, you could undo that or do different or make different changes if you also had the wideband data. In offline sorter, you can load in a wideband channel, you can high-pass filter it and turn it effectively right back into the continuous spike data that you were looking at online.